Welcome to a Lifeline Health Lecture. Tonight we will be dealing with nutrition. And of course, nutrition is a very big area, and we could probably talk about it for years, but I have picked out a few specific things that are very important and that I hope will increase or help you to increase your personal health. It might even help you to overcome some health concerns that you might already have. Our theme tonight will be the nutrients we need, and we will have, I divided it into two parts, and tonight we will be talking about the first part of it. Now, when we speak about nutrition and all the other subjects that we will be speaking about later on, I would like you to be aware that what we're doing here is not anything with the objective to heal you or whatever, but we want to give you some information so that you can make better choices regarding your own personal health. Now, when it comes to nutrition, people always ask me, well, what should I be eating? I don't have no idea what I should eat because there are so many different things. There are all these animal products like meat and fish and chicken and eggs, and some say, well, you shouldn't have them. You should only have plant foods like vegetables and fruits and nuts and grains and all these wonderful things. So let's have a look really, not about what kind of foods we need right now, but let's see what kind of nutrients we need. And in order to start with nutrients, we need to first know what they will be or what they do in our bodies. Now we have really three different kinds of nutrients that we need. We have constructive nutrients, and we have nutrients for energy, and we have regulating nutrients. I would like to compare this a little bit with a car, because most of you know more about cars than you know about your own bodies. It's sad to say, but I have always noticed that that's usually the case. So let's talk about the constructive, the building nutrients. It's just like in the car you have metal and you have fiberglass, because the outer parts are made from fiberglass nowadays. So in our body we got protein and minerals and water. That's what our body is made from. Then we have the energy that we need. And just as the car needs fuel, so we also need fuel. Now we have three different nutrients that can supply fuel to us. And the first one and the most important one are the carbohydrates. And now we have the fats, and we also have the proteins that can give us energy. Then we have the regulating nutrients. And I would compare that with your car, like with you have steering wheel fluid and then brake fluid and transmission oil and all these different things that make the whole car function well. And so we have also these regulating nutrients in us, like minerals and vitamins and enzymes and fiber. These are the four things that will help us so that our body will be able to function correctly and fast enough and properly. So let's remember that we have these three groups of nutrients that we need. Now let's go nutrient by nutrient. And what would you say should probably be the first nutrient? Do Do you have any answer? What would be the first nutrient? Well, just think about what people worry most about. People usually worry most about protein because they always tell me, where do I get my protein from? In fact, the worry about protein is so strong that I always like to call it the protein myth, because it's really a mystic thing, these protein, and the desire of people to get too much, or to get enough protein. Now, let's see where this word protein comes from. It really comes from the Greek, and it means first or primary. So the first or primary nutrient. Even the old Greeks already thought that protein was a very important nutrient, and maybe it has a little bit to do with the protein myth that's going out there. Now, but the main reason for the protein myth are probably the works of two very famous German scientists. The first of them, Dr. Liebig. Dr. Liebig was a chemist, and in the 19th century, he was able to develop a way how to determine how much protein is in a certain tissue, whether it's a human tissue or plant tissue or animal tissue. So he was able to separate the protein out of it and determine how much protein was in it. And well, to Liebig's surprise, he found out that our muscles are mainly made from proteins. And so he assumed falsely that if your muscles are made from protein, then you need to eat a lot of protein in order to have lots of muscles and to be strong. Now, I say he made falsely that assumption, and it was false, and let me tell you how false it was. If I would tell you that your car is made from fiberglass and metal, would you now just think about grinding up some fiberglass and some metal and putting that in your tank because that's what it's made from, so that's what got to give it some power, some energy? Well, you probably would think that's pretty crazy idea, isn't it? And it is. And that was exactly the mistake that Dr. Liebig made. And the problem is that this mistake is still made by a lot of people out there. Now, Dr. Liebig had a student, and that was Dr. Voigt. Dr. Voigt was an MD. He was a physician. And when he learned about Liebig's discoveries, he was excited. And he learned how to do it himself, and he went to the south of Germany, where we have a lot of coal mines, and he went to the homes of some of these coal miners, and he analyzed the food that they were eating, because he thought, well, these coal miners are very healthy and strong people, and so whatever protein they eat, that must be good for you. He figured out that these people were eating about 120 grams of protein a day, and he started to publish it, and this became known as the Voigt standard for protein, 150 grams a day. Now, it didn't take very long. It took, in fact, less than a year before the first scientists from Denmark, from England, and also from Germany started to contradict these assumptions. They said that that was much too high, and they were absolutely wrong. They were absolutely right. It was much too high, the protein that Voigt was recommending, because we need much less protein. The Government of the United States tells us that we need, I believe, about 50 or 54 grams of protein, somewhere around there. But even there, it is still much too high. We know nowadays that with 20 to 30 grams of protein a day, we have already plenty. And as you will learn in this lecture, that a lot of protein is very dangerous for our health. And I believe that the excess of protein that we're getting in the Western society especially is one of the major causes for diseases. But let's have a look at the protein itself. Now, protein is made from amino acids. And these amino acids, they form proteins just like letters form a word. And we know about 20 different amino acids. Some people say there are 18, some say there are 22. And so the numbers are not very clear. And I believe that it's because we have not defined 100% what is a protein and what is not. So let's say we have about 20 amino acids. And with these acids now, we can form all kinds of different proteins. Just remember how many letters the alphabet has, a number very similar, between 25, 26, 27, it depends on the languages. And so with these few letters, you can form books and books full of different words. And the same thing happens with the amino acids. We can form thousands of different proteins with it. And in our body, our fingernails have their own protein, our hair have a different protein, the muscles and the organs. Everywhere we have different kinds of proteins. Now, we have a very limited capacity to produce amino acids. There are some that we can produce, but there are about 10 of the amino acids that we cannot produce at all. And that's why we call them essential amino acids. Whenever we talk about essential in nutrition, it means that it's something that has to come from the outside into our body because we cannot metabolize it or not synthesize it ourselves. That would be the more correct word. So we have about 10 essential amino acids that we need to get from the outside, but also the other amino acids that we can synthesize in our body, we can't produce enough of them. So we also depend on them for the supply from the outside. Now, who then can produce amino acids? That's very important to know. Because if we can't produce amino acids, then the animals cannot produce them either. So who produces amino acids? Who is the producer for the building blocks for proteins? It's only the plants. Only the plants produce all the amino acids. And the same way as animals depend on the amino acids from the plant kingdom, it's the same way that we also depend on the amino acids or proteins from the vegetable kingdom. So what happens now if we eat, let's say, a steak? The cow did not make these amino acids that are forming her protein. It were plants that produce these amino acids. Then the cow eats it. She uses these amino acids to make her own protein. Then we eat that cow protein or chicken or whatever, and we disassemble the protein into amino acids, and we send these into our body, and then our body starts to produce our own protein with it. You know, doing this, it reminds me always of, like, if you want to produce, if you want to build a new home, what would you do? Would you go out there and buy an old home and just take it all apart and take the windows and the doors and the blocks and the timber, whatever is in there, take it all out of there and then take it to your new building site and use these used material to build a new house? Well, I believe no one of us would ever think about doing something like that, not if we have a choice. We would choose to go to a building supply and get everything new. But then, if it comes to our bodies, why would we want to go to the animal kingdom and get the used amino acids there to build our bodies? Why would we want to do that? Can you see that just through ignorance, we are really treating our body worse than what we would treat our home or our cars? Now, I want to tell you that if you are on 100% vegan diet, and we see here the word vegetarian diet on the screen, which nowadays we call that really vegan. So if we don't have any animals included in our foods, then we will get twice as much protein as we need. So why do we want more than twice as much what we need? And if you look at a pregnant woman, she needs about 1.2 times the amount of protein, 1.2. But if she is on a vegan diet, she gets twice as much. So why would she want to increase her protein consumption? And the same way, if we have young guys there or not so young guys who are trying to build up their muscles and do all these exercise and stuff and drink these I call them toxic protein drinks, because they really poison you. Why would you want to have extra protein if on 100% vegan diet, you will get twice as much as you need? So a guy that, or a woman, whoever, a person that wants to build muscles will not need more than a pregnant woman to build a new whole human being. So no way that an athlete would need more than 1.2 times the amount of protein. So we don't really have to worry about getting too much protein. And if we worry about anything, we should worry about not getting too much. As I said already before, the excess of protein is one of the worst health problems that we are encountering right now. And very, very few people are aware of it. Even our nutritionists are not aware of it because they are taught something completely different. Do you know that the regular American diet contains from 5 to 7 times the amount of protein that we need? And that's a lot of protein. That's very toxic for us. It will destroy our kidneys because the kidneys have to filter out all the acids that these proteins are going to produce. And if we get these tremendous amount of proteins, I do live blood cell demonstrations, which means I take a little drop of blood from the fingertip and I put it under a microscope, and then I can look at it. And if you get too much protein, you get something called protein linkage. Now, protein linkage is that all your red blood cells will just stick one against the other, and then you have long lines there of red blood cells all stuck together. That's called protein linkage. So we don't want to do that. And also, all these excess protein will damage our kidneys. We have tremendous problems with our kidneys right now, and a lot of people that are on dialysis right now. And that is not a very good thing to do, so we want to stay off the excess of protein. For example, if we eat 1 pound of beans, well, we probably won't eat 1 pound of beans. But 1 pound of beans contains more protein than 1 pound of meat. And that's where many people fail in this area too, because legumes are very high in protein. And also the nuts and seeds are very high in protein. And we need to be very careful. And I have a lot of people coming to me, asking me for help and advice in how to better their health. And I sometimes have people that come to me and tell me, listen, I've been a vegan for 20 years, 30 years. I just a month ago had a vegan who had been a vegan for 40 years. And right now he's suffering from a stomach cancer. There are a lot of vegans that suffer from cancer, heart attack, stroke. And they say, how is this possible? Well, because it is not enough if we are a vegan anymore. We have to know a little bit more. And if I'm a vegan and I eat beans every day, I'm getting absolutely too much protein. And there is really nothing we can do about that. So, reduce your legumes. Don't have more legumes, beans, once a week. The most twice a week, and maybe a spoonful. But don't eat that much. Personally, I eat beans maybe once a month if I eat them at all. I try to stay away from them. They're too high in protein. And then also, people come telling me, I eat about half a pound of nuts every evening. I sit in front of my TV, and then I'm just putting one nut after the other into my mouth. Yes, and then they get too much protein. We should never eat more than 4 nuts a day, no matter what kind of nut it is. So don't eat more than 4 nuts a day. If not, you get too much protein, and also nuts are very hard on your liver. So be careful with these things. And whenever you think about protein, think how to avoid it. And if you know that something is very high in protein, then stay away from it or reduce it as much as you can. Here is a little formula. This is an amino acid molecule that we see on the screen here. And as you can see, there are some interesting things in it. There's nitrogen in it. There is sulfur in it. And some amino acids contain phosphor. Now, if we cannot use all the amino acids that we're getting, then the body has to burn them as energy, because we don't have a system where we could store amino acids, like we can store fat or we can store carbohydrates in a limited way, but we cannot store amino acids or proteins. It's impossible. So if we get too much, the body has to burn them. Now, proteins, as I said before already, are part of the fuel foods or nutrients that we know. But it's about the worst stuff to burn. If you burn amino acids in your body for fuel, it's just like taking a barrel of wet rags and light them and try to burn them. What you get out of it? Very little heat. What you get out of there is a lot of smoke and contamination. And the same thing we have with the amino acids. Because when you burn them, the nitrogen, the phosphor, and the sulfur get freed. And they are very aggressive gases or substances that will immediately turn into acids. So the nitrogen will produce ammonia and uric acid. The sulfur will produce sulfuric acid. Sulfuric acid is the same stuff you got in your battery. Now imagine that, producing it in your body. Then we also have phosphor in there, producing phosphoric acid. Now phosphoric acid is even worse than the sulfuric acid. And the ammonia, remember that ammonia is a very strong acid too. Can you remember that your moms used to use ammonia to clean the toilet bowls because it burns everything? So what do you think these acids are going to do in your body? They're going to start burning cells in there. And you start burning these cells, and you have the best start for a good cancer in your body. So we want to be very careful and reduce our protein intake to a minimum. And that, I would say, should take out tofu and gluten and all these wonderful vegan things, and especially it should also take out all these textured protein stuff that we use, the TVP, textured vegetable protein, TVP, that's what it's called. You can get it everywhere in the health food stores, and the ladies like to take it home and prepare it as a meat substitute, and also you can get all these artificial or soya links and soya meats and all that stuff. I tell you, these things are probably worse than eating real meat. I would only recommend them to a person that is willing to get off meat and has a hard time doing it, and use it as a transitional food, but don't stay on it, because it is just as bad as the meat itself. And especially if you have these factory-prepared soya meats. They are full with chemicals and toxins, and I don't know how it is possible, but when I do these live blood cell demonstrations, I can also see when there is cholesterol in the blood. And I'm always surprised that the people that eat a lot of these meats, these fake meats, that they usually have a pretty high cholesterol level. So I don't know what in the world they put into them, but it can't be all vegetable products. There must be some animal products in it, because cholesterol is not produced by plants. Good. Now let's go to another very interesting nutrient. And the second nutrient that I want to speak about are the carbohydrates. Now, the carbohydrates, we make another mistake there. Isn't that interesting? When it comes to protein, where we should have as little as possible, we try to get as much as we can. And when it comes to carbohydrates, which is the best fuel for our body, where we should eat plenty of it, there we try to stay away from it because it will make us overweight. Well, let me tell you something, friends. No carbohydrate is going to make you overweight as long as it is a complete carbohydrate. So carbohydrates will not really make us overweight. We will be talking about the reason for obesity. It doesn't have to do anything with overeating. It has very different reasons. And we will discover it. Once we know, you'll be able to lose weight just like this. The fat will just disappear like ice cubes in the sunshine. But let's talk about the carbohydrates. The carbohydrates are really the cheapest fuel that's available on this planet. And only plants can produce carbohydrates, because it is the presence of chlorophyll is necessary. And only the green parts of the plant contain chlorophyll. So let's see how nature produces the carbohydrates. And you know, it's such an impressive way. It's such a simple but impressive thing that I really don't like to say nature. There got to be something more powerful than just nature behind it, because I believe it's a God who does this, because, I mean, there has to be a tremendous intelligence behind it to do what I'm going to tell you right now here on the screen. Look, we have the photosynthesis, and as you can see that the plants will use carbon dioxide, which is a gas. It's a gas that we exhale. It's toxic to us. So the plants will use a toxic gas, which they absorb with their leaves, and then with their roots, they will absorb some water. And then these two things together, they will just added together in the chlorophyll of the plant, the green part, and it needs some enzymes. The enzymes are the workers that put all this stuff together. And then we end up with a very interesting formula. See, we got CO2 here and H2O here. That's carbon dioxide and water. Now, the enzymes in the chlorophyll, they will match these two things together, and so we got CH2O. Really what the enzymes do, they just split the carbon dioxide and add the carbon atom to the water molecule, and this then is a carbohydrate. Look how easy the name. Carbo is carbon, and water is hydrate. Carbohydrate, that's where the name comes from. But now, because the carbon dioxide was split in two, so there is O2 left over. And that's O2, that's the oxygen that we breathe in. So the plants, when they produce when they produce carbohydrates, when they produce a carbohydrate, they also produce oxygen for us. And that's why we say that the plants, especially the trees, which have a lot of leaves, that they will produce the oxygen for us. But now you can see this is just CH2O, that's all there is. But inside this molecule now, God stored in there the energy of the sunlight. You can't see it, but it's in there. The energy of the sunlight is right in this molecule. And now we eat these carbohydrates in form of a starch or flour or sugar or whatever, a fruit or potato, and it contains these carbohydrates then. We eat it, and then it gets into our system, and then we use these CH2O, carbohydrate. We will use it by breaking it apart with enzymes and vitamins. We need enzymes and vitamins to break this carbohydrate down. And now we will turn it into, we need, besides these, we need also oxygen. We need some oxygen there. So if you don't get enough oxygen, you will feel very tired, because the oxygen is necessary in order to break down the carbohydrate. And we call this an oxidation process. So what we end up with at the end is, in this molecule here, we got the sun energy that's in there. And this sun energy, when we digest the molecule, the sun energy gets freed in our body, and that's what moves us. That's what makes me speak and move around. It's sun energy from food that I ate yesterday. And so then we got left over CO2 and water. Carbon dioxide and water. So the plant starts out with carbon dioxide and water and turns it into a carbohydrate. We start out with the carbohydrate and we end up with the carbon dioxide and the water. And in the process of breaking the carbon dioxide, hydrate, by breaking it down, in that process, the sun energy that the plant stored in this molecule here, that sun energy is freed, and that's what we move with. Isn't that interesting? And I would like to add here another little point that we've all heard about it, but few people understand it. You know, this whole process here is also called the carbon cycle, or this is part of the carbon cycle, because what the plants do here is they use carbon dioxide and they turn it into an energy fuel, the carbohydrate. Then we use these energy fuel and we turn this back into carbon dioxide and water. So you can see This is carbon dioxide that goes back here to the plants, and they will absorb it, and then we will digest it. And of course, anything that digests carbohydrates is part of the carbon cycle. The problem that we have with our carbohydrates right now is that we burn all these fossil fuels, and if you think about the fossil fuels, they are also called hydrocarbons. Hydrocarbons. See, that's just the same word, but the other way around. Because the hydrocarbons are produced, the petroleum is produced from living organisms before the flood, I believe. Some other people have other ideas, but I don't know how they can believe that. But that's their problem, not mine. Anyway, so now if we start burning these hydrocarbons, these petroleum, then we get a lot of carbon dioxide into our atmosphere, into the carbon cycle, and in fact we produce about 25 billion tons more every year than what the cycle is. And the carbon cycle is estimated on 300 billion tons on our planet Earth. So if we add 25 billion tons to it, you can see that we add about 8% of carbon dioxide to our atmosphere that the plants later on will not use up anymore because there are not enough plants on the planet. Well, that's just a little note about the carbon cycle because I find it very interesting. And we will be talking about the carbon cycle hopefully later on because it has a huge importance for our health, much more than most of us can even imagine. Now, it's important to avoid empty calories. Why? Why should we avoid empty calories? Well, you know, if you want to use, for example, carbohydrate, you saw already that we need enzymes to break it down, and we need vitamins to be able to use it. So we need other substances. So you can't just live on white sugar because there's nothing else in it. So we need complex carbohydrates that come with all the other nutrients that we need in order to be able to use that food. And, you know, I always like to talk about God's little packages of love. Let's just look at the carbohydrate, let's say in a wheat kernel. All right, the starch, the flour that's in there, that's pure carbohydrate. Now, God does not produce pure carbohydrate, refined carbohydrates. He packs them in a layer of gluten, and then he puts around it a layer of fiber. And between these gluten and fiber, we'll find some vitamins, and in the germ, we'll find some oil, and we'll find some, of course, the fiber in there, the vitamins, the minerals. So all these things that we need, it's all together. That's why we call a whole wheat grain or berry, we call that a whole carbohydrate because it comes together with all the things that God has packed it in. And we need it. If we get it that way, we won't have any deficiencies. But the problem is that we are trying to outsmart God. So we take this wheat kernel and we send it to a factory, and then to a mill, and we tell Mr. Miller over there, please could you grind this thing up now and take all the fiber out, and with the fiber you can hopefully also get all that gluten out, or most of it. And of course Mr. Miller says, oh, you know, there is this kernel in there, this germ in there, and between the germ and the starchy area, there's a little membrane, which is the plant's stomach, and in these germ and the membrane, we'll find a lot of fat in there. So the miller found out that if he leaves that germ in there, then the flour will get rancid, because if oil is exposed to the air, it will just plain get rancid. There's nothing you can do about it. Well, yeah, there is something you can do about it. You can take the germ out, and that's what he does. And, well, it's sad, so then we get these white flour, and that we call it then we call that a refined carbohydrate. But people know already about these things, and so Mr. Miller says, he says, well, you know, we got to do something about it. We got to enrich this flour. And so he starts to enrich the flour, and he adds to it a little bit of vitamin B, I believe, and he adds a little bit of iron to it. But he took out about 20 different minerals, nutrients already. So by the refining process, we lose about 20 different nutrients. And then he adds iron and vitamin B to it, and then he calls that enriched. Well, let me ask you a question, guys. If somebody steals from you $20 and then gives you $2 back because he feels bad for you, he says, well, maybe you need some bus money to get back home, so he gives you $2 back. Would you feel enriched? Well, you wouldn't feel enriched, would you? Of course not. But Mr. Miller calls that enriched flour. And we eat enriched flour because, man, we're really getting something good now. And you're getting something good, no doubt about that, because you get a lot of iron. And you know that one of the worst problems in health problems for elderly people is the accumulation of a lot of iron in their body. And that it has to do a lot with all these mental diseases that we start getting in a higher age. So it's really something that we need to watch out for. Okay, so we don't want to use any white sugar or any white flour. We only want to use whole grains. And good, I think that's all I want to tell you about this slide here. Let's go to the next one. Oh yeah, now this here is a very interesting thing too, because you'll see a lot of names here that you know already. And it's not important that you understand really what they all mean, but I just want to make you understand and know these names, because there's one thing that we have to do. We have to learn how to read labels. Well, there is one way how you can avoid reading labels if you do what I do. Never touch anything that comes from a factory. Nothing, absolutely nothing. If the food that comes into my home is not the original way that God has made it, it will not come into my home. So then I don't have to read the labels. But I guess you are quite a few steps away from getting to that point to getting rid of all these foods, because if you would decide to get rid of all them tomorrow, well, some of these families out there, you might be starving to death because you don't know what to eat and how to prepare it. So you need to learn how to read labels. Now, what we call carbohydrates, it is also called saccharides. That's the technical name for it, saccharides. Now, we have different kinds of saccharides. We have monosaccharides, which consist of one molecule, of one carbohydrate molecule. And monosaccharides are like glucose, which is the sugar in our body that we use, like fructose, which is the sugar in fruits, or lactose, which is the sugar in milk. These are all monosaccharides. So if you see these words, monosaccharides or saccharides, on a label, be aware this is all sugar. Then we have disaccharides. We have the di or disaccharides. I don't know how you pronounce that exactly in English. So these disaccharides, they contain two molecules. Of course, mono means one and di means two. So they consist of two molecules. And in this group, we will find sucrose. Now, what's sucrose? You know, most of you eat sucrose every day. It's the white table sugar. That's sucrose. And it consists of one molecule of glucose and one molecule of fructose. That's what sucrose is. So they put sucrose on the label. Be aware, it's white sugar. And glucose, fructose, these are all sugars. Then we have the oligosaccharides, which have between 3 and 10 molecules. These are the flours and the starches. They're a little bit more difficult to digest. And then we have the polysaccharides, where we could have like 10,000 different molecules all stuck together. And then these chains are so long that our body cannot break them down anymore. And this is then called the fiber. So these are the different saccharides that we have. And I would like to, before I get into the next nutrient, let's leave that for our next lecture, really, because our time is almost over. And I would like to add a little bit more to these, the carbohydrates situation, because so many people out there try to avoid carbohydrates because they think they get fat with it. And it's not the fact. You do not get overweight from overeating carbohydrates. If that was the fact, then I would not be walking. I would be rolling through the area because I eat a lot. I eat at least half a loaf of bread every day, and that's just my dessert. So, don't be afraid of carbohydrates. They are not the ones that will make you overweight. What will make you overweight are only acids and toxins that your body is not or has not been able to get rid of. And so he will start to produce fat tissues if you have a pretty healthy body, because some people have a very sick body and they stay skinny. They are full with acids and toxins, and they just stay skinny because the body doesn't have the strength anymore to produce the fat tissues. But if you have a good, healthier body, then you will start to produce some fat tissues, and then the body starts to deposit all these acids and fats in the to deposit the acids and toxins in the fat tissues, so that they will not hurt our organs. That's the reason for overweight. The reason for overweight is in being very acidic and very toxic. And now, if we get on the right diet, and that's part of our seminar, now, you keep watching for it, because we'll teach you how to lose weight with a full stomach, because you can eat 10 pounds of potatoes a day loaded with carbohydrates, and you can lose with that 20, 30, 40 pounds of weight per month if you want to. Like I said, what you need to do is, if you want to lose weight, you have to get rid of the acids and toxins. And once that fat tissue starts to clean out, the body will just burn it. So I don't need that storage anymore, so he will burn it. And I think it is a big mistake to be afraid of carbohydrates. But of course, now, if you eat refined carbohydrates, then you will be in trouble. And that will make you overweight, but not because of the calories, but because these refined carbohydrates will start to produce a lot of acids in your body when you burn them. And that's what will make you overweight, right? And so don't be afraid of these acids and don't be afraid of the carbohydrates. Eat plenty of carbohydrates. Now, where do we find the carbohydrates? I haven't told you that yet. The carbohydrates, we find them in the most concentrated form in the grains. And that's why they are called the staff of life. The rice, the corn, the oatmeal, the wheat, the barley, and all these wonderful grains. They are loaded with carbohydrates. They're very high. And then we have the tubers. Well, tubers are very high in carbohydrates too, but not as high as the grains. So if you don't want a lot of carbohydrates, if you want to reduce them, then eat potatoes instead of eating rice, for example, because potatoes have much less carbohydrates. And another group for carbohydrates are our fruits. The fruits are very high in carbohydrates too. And the carbohydrates are in a different form because they are more in the form of fructose in the fruits. And we don't digest it as fast as the glucose in other things like in our grains and tubers. So the grains and the fruits are our good sources. And of these you may freely eat. I like to talk a little bit with biblical sound sometimes, even though some people don't like it too much, but you know what, don't worry about it. Because what I'm teaching here, to be honest, is that it is all information that comes directly from God. And I hope I'll have a chance one day to tell you how we got this information. And so it's an information that comes from God, and in many parts, in many areas, it will contradict the knowledge of the world. And so be careful with the protein, reduce it, eat as little as you can. If you have an avocado, have a quarter of an avocado a day because it's very high in protein. Don't eat more than 2 bananas a day because they're very high in protein. There's protein in oranges and tomatoes. It's everywhere, so don't worry about that. You'll get enough protein if you don't eat only refined products because they take them out usually, or they destroy them because of the industrial process. And eat freely of carbohydrates, grain, unrefined grains, and eat freely fruits, and hopefully fresh, uncooked fruits. And you will have made a wonderful step towards better health. Thank you.